Okay, hi, good day, everyone. I hope your day is going fine, and welcome to Machine Learning Lagos. It's uh, it's a community based in Lagos, Nigeria, where we discuss things machine learning based and AI based. So, for this session, this is going to be our first office hours. And okay, before I start with that, I would just briefly give like a summary of what we do at Machine Learning Lagos. So at Machine Learning Lagos, we have several programs such as our technical sessions that happen every month, likely like the third or the fourth week, where we bring experts to come discuss technical topics. We have our study jams, and yeah, those are like the two major things we have. And lastly, we're starting something new called office hours. So office hours is a bi-monthly session where we bring Google developer experts and Googlers in the AI space to come talk to us about Google AI and its offerings, the features, and some technicalities around it. And to start a kickoff with our office hours, we'll be having our first session today, and it's no one other than Henry. So I would be sharing. Hi, Henry.
Hello.
So I would be sharing my screen shortly. Okay, so this. So yeah, welcome to ML Lagos office hours. So ground rules for we used to have some ground rules, but since this isn't our typical Google Meet call, I omitted some rules. So if you are in the same if you are in the chat for the YouTube stream, you should be respectful to everyone, engage actively, share your questions because we'll be taking a lot of questions after the session. Keep the discussion focused on machine learning and AI, and avoid spamming. Then join the session and stay until the end because every moment of this session counts. Feel free to ask questions during the Q&A via the chat section, and most importantly, have fun during the session. So yes, this is the I omitted I was meant to write office hours. So this is our office hours agenda. We have the welcome, we have the session, the Q&A, and lastly we have the announcements. So for our first session, like I said, we'll be having Henry, who will be taking us through building scalable machine learning models with JAX and Flax. So this is a very interesting topic to me because I started learning JAX earlier this year, and I'm very invested in this session. So a bit about Henry. Henry is an AI research engineer in large scale NLP and computer vision. He went through the Google Africa developer program in the past before studying up to a master's in AI. He has worked in several firms and wrote NanoDL, an open source JAX library for building transformer models, which made him a GD for machine learning, which I think they now call GD for AI, because I got an email a couple of days saying they are changing everything ML to AI. So, and lastly, is the co-founder and the CTO of Cactus Compute, a distributed deep learning company. And yeah, on this call, because we're streaming via Meet, we also have Roman, is co-founder with us. So yeah, moving, I think that's all from me. So over to you, Henry. I'll stop sharing my screen and the floor is yours.
Hello everyone. So I'm a big fan of Google JAX, and if we're kind of connections on LinkedIn, you probably like see me talking about JAX a lot. And so in this presentation, I'm gonna walk everyone through building models with JAX from beginner level to advanced and intermediate levels. So I prepared a notebook, which hopefully everyone gets to access after this stuff. And we shall run the program, the presentation with the notebook. Um, I don't know if my screen is visible.
Yeah, it is.
Okay, thank you. So first, JAX is just another machine learning framework similar to PyTorch and similar to TensorFlow. And for this notebook, these are kind of like the prerequisites if you're going to run this on Jupyter Notebook. But for Google Colab, we don't need any of that. And so for this start, we're going to change this runtime to CPU. So we will demonstrate JAX's power and efficiency appropriately. So I split this into sessions. I'll walk through, like explaining, like what JAX really is, and I like to call it NumPy on steroids. And the components that make up JAX, just-in-time compilation, automatic differentiation, the XLA compiler, and also one very interesting feature of JAX, which is its functional paradigm. And then also we'll go to actually building deep learning networks here, and then I will walk through like some performance optimizations or tricks we use to make machine learning scalable, and how it's achieved in JAX. And then sharding and distribution. This is how to like split your compute across multiple devices efficiently. And then finally, I will give like a brief example on NanoDL. I haven't spent so much time on the project in the last 1 year at least. And then Google's max text and max diffusion repositories, which you use for training up to 1 trillion parameter model. So that's for serious scale. NanoDL is for your few billion parameters of transformer. So first, can you see my code, or do I need to zoom in more?
Yeah, I think I can. Yeah, you just a bit.
Okay.
Yeah, that's fine.
Okay. So the first cell here is just like a function decorator. So we're gonna use that to time a bunch of our codes. We're gonna like average its execution 10 times, right? So we're gonna execute a function and then we take the average execution time. So first, we're gonna time JAX is kind of NumPy on steroids. It's super fast. It's optimized for both CPU, GPUs, and TPUs. And this cell, for example, executes creates like a relatively large tensor in NumPy. With 10,000 by 10,000, like dimensions, and then executes it, and that's how, and takes the square of this matrix. And that's how long it takes. And touch should be faster, hopefully. Yeah, touch is fast. And JAX is much faster. So to execute, like square of a very large matrix, this is 10,000 by 10,000 elements. So that's a lot of elements, and that's about 100 million. And it took a NumPy 0.13 seconds. It took square, like a PyTorch 0.07 seconds, and it took JAX 0.02 seconds. That's a magnitude of orders faster than typical frameworks. And this is just CPU. We haven't even moved to GPUs and TPUs yet. I'm probably just going to save that for the last. So next is just-in-time compilation, another feature of JAX. Oh, by the way, so this here, I also wrote this to show like the similarities between all the frameworks. So for JAX basically copies like uses the NumPy's APIs. It behaves like NumPy, and that's why it's NumPy on steroids. But I will walk through this. I will explain this sometime, somewhere along the line. So first, just-in-time compilation. So JAX's JIT, a lot of like frameworks have like compilation, like just-in-time compilers. You have Number for pure NumPy. You have Touch that compile. JAX is a bit more efficient. It uses kernel fusion really well. And here is an example. When this is a simple square function again, to obtain the pre-compiled version, you pass a function called JIT. You call JAX.JIT on the function, and here the natural square, like first one took about 0.003 seconds. This one with JIT took about like about half of that. But then you get a lot more benefits in this JIT compilation when there are a lot more operations. So most times you don't JIT just summations and all that. You often use JIT when there are multiple operations, and you want JAX to create some kind of efficient compute execution graph behind the scene for you. So for here, for instance, MATMO involves a lot of like multiplications and additions, and then we square it also. So we expect to see like more like performance improvements. So that's the long function without the just-in-time compilation, and this is with just-in-time compilation, how long it takes. And that's it for JAX's just-in-time compilation, like a section. I'd strongly advise everyone to kind of like read through a bunch of this stuff I just wrote here. But JAX is too comprehensive for one session, so I'm going to breeze through a couple stuff and then give you access to this notebook. So next is automatic differentiation. So a lot of times in numerical compute and like machine learning, you need like to compute the gradients of complex functions. So this, for example, is an unnecessarily ugly function. I just decided to put something very nonsensical there, and like we take the gradients. This is similar to how you like get the gradients in NumPy, in Touch, and all of that. But JAX has an added function called value and grad. Now, value and grad, once you just put this decorator on your function, it literally gives you the output and its gradients at once for the same function. And this comes in very handy when we go to actually building models. So in JAX, you create your model, and in your forward pass, at the same time, you get both the output and the gradients. So you don't need to do lost dot backward. So you do like, you iterate forward, you iterate backward. It compiles the graph, this graph, efficient in such a way it merges the forward and the backward graph. And that's like another trick with JAX, which makes it really efficient. Next, the X in JAX stands for XLA compilation. Now, XLA compilation, I've been like talking about execution graphs, optimal execution graph, and all that. In JAX, the graph we use is called the HLO. And it's one of the most stable, graph representations out there. So we write like a function, any function or any model, JAX lowers it into an execution graph. And the sweet thing about this graph is you can save this graph, right? And you can create a PyTorch model, the same PyTorch function using just this graph. You can recreate it in TensorFlow using just this graph. And you can also execute this graph directly yourself if you know how to use OpenXLA in C++. So, when it comes to porting, it's a hot mess out there in machine learning. It's a big problem. And this kind of like solves the issue. So, I think I'm going to explain this much later. For now, leave that part. Now, the caveat. JAX is very good. It's very lovely. But there's one thing to note, which makes it a bit difficult for, like beginners. One, it has to be a functional, functional function. And a functional function and the whole functional paradigm involves pure functions. So it means variables are immutable. So in NumPy array and PyTorch, you can create like an array, and then you can change the value at a particular index. You can randomly assign stuff. In JAX, this is going to throw an error. It's going to give you an error that you probably wouldn't really understand unless you really knew what you did wrong. Yeah, there you go. And instead, what we do, we use this .set API. However, this creates a whole new tensor. It's a bit efficient in the sense that it depends on the way these tensors are represented, but it still doesn't really make sense to create new tensors every point. So a lot of times you have to be careful with like changing variables inside your JAX functions. It's a no-no. It's not allowed. It's gonna break your code. There you go. That's how you do it. Next, it has to be pure functions. Pure functions in the sense that whatever goes on there inside the function shouldn't affect some variable outside, right? So imagine this dummy example. I created a counter, and then I created like a function that increments the counter. Once you call this function, the value in this counter changes. The state of the counter changes. It goes from 0 to 1. And if you call it again, it goes from 1 to 2. So it affects the state of a variable somewhere else. And it's called side effects in programming computing. And this is what makes a function impure. A pure function, you don't let it modify something outside. You pass in the two things you need to do. And most times when you call this function, you need to do like counter plus equals pure function x counter. You see what I mean? So you have to explicitly modify stuff. Next is explicit state management. Also, because we want to reduce side effects, JAX is optimized in such a way where during execution things don't just change, right? And it's one of the reasons why it's fast. But that means when it comes to creating random numbers, it's not truly random, right? So the variables, you have to manually pass in your key, and once you create like a random array with the same key, it gives you the same value every time. However, JAX also provides like an additional like functionality called split key, which you can use to simulate some kind of randomness. So every time you split the key, it changes the random variable. And but you always have to pass this key in random stuff, sadly. And also one of the so this is function composition. So a lot of times JAX often prefer things being functional, where things are broken down into function. So this is just like me explicitly jitting these two functions together. So it's equivalent to computing this of that, right? And also now this composed function, we can map it across every element of this array, using a VMAP. VMAP is quite kind of like something you also see in NumPy and in PyTorch. So JAX also has that. So next, down to the machine learning part now. So I previously explained JAX from a computing perspective as a general numerical computing stuff. So whether you're a mathematician, you're a biologist, and you want to run equations really fast, you can use JAX just as you would normally use like your NumPy array. Now for machine learning, you could use Haiku, and you could use I think there's Equinox, and there's a lot of them out there. And also you can write your function in JAX, natural JAX, and just run it as you would. But JAX also has sister libraries, one called Flax and another called Optax. Now, why Flax is often recommended is that it makes defining models feel like PyTorch, just like that, right? So in PyTorch, you have def init, and then you have def forward. In JAX, all you need to do is def setup and def call, and it's basically the same thing. But because JAX is because it's what it is, you need to statically pass the type for that. Now, once you create a model, we always because this execution graphs are stateless, we have like an additional state. Flax gives you something called train state. So it's kind of bundles your model, the parameter, and everything you need for it into one shared container. So it gives you like a natural feel. So you initialize the model, for instance. You also initialize the parameters. And remember the example I gave with passing the counter and passing everything differently. In machine learning, you always update the parameter. So it's kind of like a side effect. So for JAX, you have to explicitly pass the model and the parameter. So you need to initialize the parameter by giving it a sample shape, and then the RNG, which is like the key, the key you generate. And then Optax has every optimization feature. Like it has optimizers, it has losses, things you normally need to like optimize for the whole actual training. So you create that, you pass in your apply function, and you pass in your parameters and you pass in your optimizer, and it creates that contained stuff. Now, for the loss, this is our loss function, nothing special here. You simply pass in your parameters, and then you get the predictions by applying, by passing in the parameters and the inputs. Again, it's functional, so you need to pass in both the inputs and weights. It doesn't maintain its own weight entirely. And then for the trend step, you need to, this is where we use the JAX value and grad. For instance, like in one forward pass, we get both the loss and the gradients without having to do like an additional backward. And we apply the gradients to the state, not to the model, because we can't alter the model itself. But the trend state we created, we can change things. We can update the parameters inside that trend state. It's just like some Python container. And we can return the state and the loss. So now, for a training of your model, it's exactly the same like PyTorch, literally, except that you break these functions down, right? You break them down into functions. You create your trend states, right? And then you still iterate. A lot of times, your PyTorch data loader works with JAX anyway. So it follows the same way it iterates through for epochs and for every batch, for every item in every batch. For every batch in the, like the data set. Literally exactly the same thing. So here's an example of I haven't imported this. What am I doing? So this, and then sample training. Yep, there we go. Super fast. Now, one of the benefits to having these parameters external is that this parameter is just a dictionary. So anything you can do to a dictionary, you can also do to this parameter. So absolutely nothing special there. And then talking about this parameter, let's go to this performance optimization step. The JAX provides what we call PyTrees. It's some kind of data structure that generalizes nestable, like objects, like arrays, like Python lists, like dictionaries. And you can run operations. You can run really efficient operations on these. So let's say tree map, for example. Let's say you want to map a function to every element in your parameter. Let's say you want to convert every array in your whole parameter into floating point 16. This is literally all it takes, right? Whether you want to quantize, if you want to quantize, all you need to do is to post-training quantization. You need to just change your internal logic. For here, we literally call this internal function on our parameter. We simply map the function across our parameter dictionary. So every array there is converted to FP16. Just that. You don't need to create funny things. And this is also very important when it comes to counting the number of parameters in your model. Literally, just count the size of every leaf. Here we use PyTrees leaf for that. For VMAP, I already explained the vectorization part. This is just like a sample softmax implementation. Okay. Next, for learning rate schedules in JAX, you need optax. And it's literally optax. Optax has very simple APIs. It's not nexted. So if you have like a function you want to call, let's say it's optax.adam, it's optax.mse, it's optax.exponential decay, it's optax.everything. It's very lightweight. So literally optax.exponential decay, we create your stuff, and then you chain them into your optimizer, right? So there's the initial learning rate, and then there's the the scheduler and its scale. And you simply need to pass that optimizer to your trend state as you normally would. Now, about the building scalable model part of this whole presentation, one part is gradients, like accumulation. One thing we're going to talk about. So a lot of times, let's say you want to train like a 1 billion parameter model on floating point 32, you're going to need like 4 GB of RAM for the forward pass, and just multiply that by 3 to understand how many gigs of RAM you actually need. So about 12 gigabytes of RAM. And let's say for sake of accuracy, we have like an NVIDIA 3090, which is like 24 gigabytes of RAM, and you want to train a 2 billion parameter model. You see, you're actually going to max this stuff out. It's insufficient, just for one, even one, like each one batch. So for that, gradient accumulation involves not, like batching the whole thing, go iterating through the data sets one after the other, but accumulating the gradients. So it's like you calculate the gradients, you kind of add it to the like existing gradients as it is, and then you average it out eventually. Now this, if I go deep on this, it's gonna bore people. So I kind of like added like a bunch of comments for when you're going through the notebook. And then ultimately, sharding. Let's say even with all of these tricks, you still need more GPUs. So for this, I have to actually change my runtime type to a V20, 8 TPUs. Like I need to import a bunch of stuff again. Okay, so a lot of times when working with, let's say, much bigger model, like with billions of parameters, you sometimes need to run computations on multiple. You want to distribute these computations to multiple GPUs, so they work together to give you your results. And JAX, I think that's one of the biggest benefits of JAX. With PyTorch, it's very doable, but you don't want to look at the code. It gets really nasty. And with JAX, it's very straightforward. So it's JAX gives you a bunch of APIs. One, there's JAX.local device count, which gives you how many devices you have in your environment. So right here, I have like a bunch of TPUs, about 8 of them for this, like walkthrough. So let's say we have like matrix multiplication. Like we want to create like matrix multiplication. Like this is just like A and B like data for matrix multiplication, and we want to like distribute it to multiple GPUs. In reality, all we need to do, if you don't need too much flexibility, is to use jax.pmap. That's literally all you have to do. But you have to reshape this data by the number of devices. So when I say reshape it by the number of devices, let's say if you have, if let's say this is 16 by 32 by 64, it has to become 8 by 2 by 32 by 64. So where 8 becomes like the number of devices, if that makes sense. So you need to, it's the same as you shaping your data in such a way it's split by the number of devices. And once you literally just call jax.pmap on this function, and then you call the function again, it computes your stuff super fast, right? So this is the result. The result should be like 16 by 64. And then so these are like, it's distributed across 8 devices. These are like, you have to just concatenate all your samples. Now, for more advanced situations, we use PGIT and mesh. Now, this is how TPUs, kind of like the arrangement of TPU chips, right? So there's like a bunch, like different chips for them. And these two functionalities gives you the ability to choose which chip does which, and it gives you the ability to choose how it's overlaid across the whole GPU. And there's a running joke, if you actually need, or if you've gotten to the point where you need to understand these concepts and use them, then you probably should be working for Google DeepMind or OpenAI, one of the big guys. It gets really involved. So this is an example. Again, there's a lot to talk about here, but I chose to, like you can virtually map out the TPU arrangements however you want. For now, I chose like the cube selection. So 2, 2, 2, like 2 by 2 by 2. And these are kind of like in the mesh, you kind of like your mesh is kind of like an overlay of your bunch of like devices. And You have like just give the coordinates names, and then you write the partition specifications. You get it from JAX.sharding. Partition specification, how it's gonna partition the data. It's gonna split it across this, across this, across that, but like not across this dimension. And again, you have to reshape it. When I say reshape, obviously it's to make sure it's it matches the dimensions anyway. And then you simply call pgit. So it's kind of like parallel just-in-time compilation of this stuff. It compiles this in such a way where it's aware of its configuration. And then with mesh, you execute that. And you get all your computations for which like you collate everything from each of these chips into one. And yeah, so most times when you want to build like, I don't know, like 7 billion parameter model, 10 billion parameter model, you might get away with only needing PMAP. But when you want to build like 1 trillion parameter model or hundreds of billions, you may need to like start defining your partition specifications, especially if you have few GPU resources. And then next, I created a library that abstracts all of these called NanoDL, which was one of the reasons I was contacted for this, and also why I was invited as a Google developer expert in machine learning and JAX. So here, a NanoDL is quite involved. So I'd recommend you go through the repository yourself. We have like the array data sets. I kind of like create, it's for building tiny transformer. And by tiny transformer, let's say you want to build like, I don't know, like 100 million parameter model yourself. This can build it efficiently and it can train it on multiple GPUs for you. However, if you want to build like much bigger models, I strongly recommend using Google's MaxText and Max Efficient for those. So for NanoDL, you have this. So we're gonna like this is like an example transformer dimensions I created. These are just dummy data. This is just generating dummy data, and then you can use NanoDL's array dataset and its data loader. And I have implementations of a bunch of these models: Mistral, Llama, GPT, all of those. So you want to create like your own tiny GPT model, you can use this. Now, 8 TPUs is kind of like these are very cheap, not cheap TPUs, but like V2, not like V5. So it should be, I don't expect it to be too fast when training the transformer model. Transformer models are incredibly difficult to work with. But yeah, this is basically all you really need to do. Like to train like your own equivalent transformer model. Just load your data sets, tokenize them, and just create like a data loader and like give it to NanoDL, and it's gonna train this model for you. And then so for MaxText is not a PIP, it's not a library you can just PIP install. It's a full repository which you're gonna have to clone, set up, and then execute in a cloud environment with multiple clusters, or with like lots of GPUs. So if like you're working at that scale, then we strongly recommend MaxText. So yeah, so that's NanoDL training. Again, I don't expect this to be really fast. We're trying to train a GPT-4 equivalent on only 8 GPUs. So yeah, I think that's JAX in a nutshell. Sometimes people kind of like make it look like it's too difficult because of the whole TensorFlow thing. TensorFlow is a bit like tricky to use sometimes. So JAX is actually one of the easiest libraries you can use. And I mean, who doesn't want this magnitude of like computational benefit, right? If you use JAX really well, you can benefit a lot from like its performance. Okay, and I think that's it. Oh yeah, that's none of your training. So I think I'll stop sharing for now, if that's all right. And I think there's a bunch of questions, right?
Yeah, we have a bunch of questions. So I would go back to sharing my screen. Okay. So yes, thank you, Henry, very much for that session. So before I proceed, during the week or like last week, we asked people to send in their questions or questions they will have for this session, and a couple of questions came in. So I would be sharing the question and reading it, and you'll be providing answers. So also, we have some questions on the live chat, and I'll be getting those questions. Basically, we'll try to see how many questions we can answer
Mhm.
during the time frame. Yeah. So I would start. So the first question is, what challenges do teams usually face when transitioning from PyTorch or TensorFlow to JAX and Flask? Flax. Why do I keep on saying Flask? And Flask. And how can they overcome them?
So yeah, I think honestly, the only challenge you probably face is Jax's functional paradigm. It's a lot to take in, especially if your background is in a pure computer science, where you understand your thoughts in functional programming. So it's something that needs getting used to. But also, there are lots of benefits that makes the trade-off worth it, if that makes sense. You get like juiced up performance, and you get like really usable interface when it comes to scaling your models.
Okay, that's a very good question, and so an answer. And I think I faced something like this. So I was working with a PyTorch notebook, and I was trying to implement it in JAX, and I ran away because basically it looked very steep for me. So I just followed PyTorch and I continued. But I am currently going back to JAX and seeing how to go about with it. So the next question is, how does Flax compare to other libraries like Eiku in terms of flexibility and ease of use?
Okay, so Haiku was initially developed by DeepMind team for their own purposes. And why I included this information is because it's a bit too low level for most people. So if you come from PyTorch, Haiku is not for you, right? It's things are broken down too much and it's very functional also. So in Flax, you get these PyTorch-like interfaces for defining your model. So it feels, like it feels a bit more natural. So I strongly recommend using Flax.
Okay, thank you.
But
Next question.
yeah, actually,
Sorry.
so if you have some layers you've implemented in Haiku, you can actually code them in a Flax module. They're
Oh,
all JAX behind the scene, and they're all lowered to HLO in JAX.
that's pretty.
Yes.
That's it's interesting. I'll check it out.
Yeah.
So, yeah, next question. Given that JAX computations are heavily optimized, debugging can be tricky. What are the best strategies for debugging issues in JAX models?
Okay, so JAX, debugging in JAX is quite challenging. But I think one of the good things, a lot of like the errors you're gonna see are sometimes too low level for typical machine learning engineers, in the sense that we're used to Python, we're not used to compiled stuff with compilation and all that. So you're gonna see like the error I showed, when you try to assign like you try to mute an array, it gives you like a bunch of stuff. But the good thing about it, it also points you to like a documentation that explains that. So it's I think it's one of the cool stuffs in JAX. So I won't tell you it's like the debugging is very straightforward, but JAX is quite expressive. A lot of times you should know what went wrong if you build from scratch. And
Mm.
if it's kind of like a runtime stuff, you're gonna get like points to the doc to read up or like on different things or on why it probably happened.
So it's similar to Julia, because Julia's debugging is quite funny at times. Yeah, yeah. So, yeah, looking at the two, the error stack or the stack trace is very scary at first, but going through it, it's quite easy to go through and understand. Especially, like you said, if you are building from scratch, you should know what you are doing and how it went wrong. So
Exactly.
Yeah. Next question: how does JAX integrate with libraries like Organ Face Transformers or Open AI's Triton for specialized use cases?
Okay, so first, Hugging Face, you can extract a lot of models in JAX. Actually, you get like a Flax equivalent of the model with Hugging Face. I think it's actually very easy to do. So it integrates quite well with Hugging Face. But my problem is that Hugging Face is a bit too optimized for PyTorch. It doesn't, I don't feel it, kind of like maxes JAX out. It really uses JAX to the max, but Hugging Face is really fast. I mean, it's a very good library. For Triton, I don't think you actually need Triton for JAX. I mean, you can't use it in JAX anyway, so maybe I'm just like making an argument. But you don't need Triton in JAX. JAX's kernels are highly optimized, and that's why you see it perform really fast on CPUs. It's like very well optimized. So we don't use Triton in JAX, but JAX exposes an API called Pallas, Tallas. Very few people have heard of this. I haven't met more than two people who've heard of this, and they were all DeepMind engineers working on JAX project itself. So Pallas is kind of like a micro language. So there's JAX.Pallas, where you can write your custom kernels just like you would Triton, but it's not CUDA. It's a bit different, and it can execute on both GPUs and TPUs. So if you get to the point where you need to write custom kernels, use JAX.Pallas.
Oh, that's interesting. I learned something new today, apart from everything. Interesting. Okay, so next, what's your favorite? So I think this is more of a personal question. What's your favorite feature in JAX or Flax that you wish more people knew about?
Stable HLO.
Oh,
Yes, it's internal representation. It's really cool. So in my previous job, we always had like issues with porting model. Porting a model is actually very complicated. So like extracting the model graph for execution on, let's say, edge devices, it's very involved sometimes. And there are a few like ways to do that. Like if you work with legacy like PyTorch and all that, there are many ways to do it, but you can run into a bottleneck, right? It's not guaranteed to work all the time. With JAX, it uses stable HLO, and it's actually very stable. Whatever you extract can be executed in pure C++ environment. It can also be converted to PyTorch, and it can also be converted to TensorFlow. Literally, yeah. But I think PyTorch has joined the whole HLO movement. So Google created XLA and HLO and all of that before, and then they open sourced it. So there's an organization called OpenXLA that maintains the project now, and Facebook is part of that organization now. So there's Touch XLA, and it's kind of like a really cool backend that everyone is trying to work with now.
oh, that's interesting. Very, very interesting. Let me see. So, yeah, another personal question. What advice would you give to someone just starting with JAX and Flax? Any must read resources? So I'm very interested in this question. I know you might say, oh yeah, the documentation, because every time, yes, because every time I meet someone and I'm like, oh, I'm learning JAX, and they're like, yeah, just go to the documentation. The documentation, the first two pages are very friendly, but you see from the third page,
Yeah,
it's like super scary, especially if you are not coming from a very good machine
and
learning background, or you are
engineering.
used to writing, yeah, an engineering background, or you are used to writing maybe high level code and all those kind of things. So it might scare you at first because there are a lot of things flying around and the whole thing is just so chaotic. So yes, apart from the documentation, which everyone knows, what advice will you give, and like what resources would you give for us to start learning or continuing our journey in JAX?
Okay, so if you want to learn JAX, I'm gonna be honest with you. All the resources out there, I guess it's a bit different for me. My first framework was PyTorch actually, and that was like in 2018 or so. And then after PyTorch, I became like a TensorFlow fanatic. So I used TensorFlow for a while. So when I got to JAX, it wasn't so scary. I don't know if that makes sense. So if for experienced people, when I say experience, I mean like just generally people with coding background and all that, just Google autodidacts, AUTODIDAX. So this is where the JAX team kind of like a tutorial on how JAX was actually designed and its internal implementation, how to build your own tiny JAX. So it's going to expose you to the paradigm. But if it's, let's say you're a first-time programmer, JAX is also very friendly, and that's one of the reasons I had to like create this code walkthrough instead of just talking about JAX. And if you want, like you could kind of like give people access to this notebook if you want. It's something you can follow cell by cell, and I'll actually add some edits, like some improvements on that to make it more easy to follow. So that's one. Else, the third option is for you to start using JAX as NumPy for a start. So personally, I don't use NumPy by itself anymore. I use JAX NumPy because it's faster. And because the same code, I don't need to do, so in PyTorch, you need to move touch to device, to move to CUDA, to move to that. JAX, you don't. It does everything for you automatically. So I can write my JNP code, my JAX NumPy code, and it runs on CPU faster than NumPy, and it runs on GPU super fast. So I think maybe you can start using like JAX NumPy in place of NumPy for a start.
Oh, I think I would look into that because this question is very personal. So also I think a follow-up question that might come is I don't know, I might be wrong. I haven't seen a lot of repos or a lot of things around JAX. It's like it's still in its early phase, and people are there is this thing about, oh, you're using JAX, don't use JAX, use PyTorch. I've seen a couple of arguments around that. So like, what's your take? I think it's even linked to the next. It might be linked to the next question, but like before that, like, what's your take on those kind of things? Because I personally I feel Jax is cool. Because what drew me to Jax was the catchphrase. It says "numpy on steroids," and I was like, okay, I know numpy is fast to an extent. Like it's pretty cool. People use it, but then you're saying something faster than numpy. So that's what actually even drew me to know to Jax to start learning it. So like what's your advice? Do you advise people to start making more resources on JAX, building things with JAX, or just maybe abandoning it? Or like, what do
So
you think?
if you work for smaller companies, you're better off with PyTorch because PyTorch is user friendly. If you're stuck, like there's a lot of like resources out there for you to use in PyTorch, and a lot of repos are in PyTorch because it's more user friendly. But if you're working for larger companies, you almost will always use JAX. At Google, they exclusively use JAX. Now, I think a lot of teams are actually leaving TensorFlow and put into JAX completely. At XAI, Elon Musk's company, they exclusively use JAX also. The Grok, everything is in JAX. At OpenAI for DAL-E and like compute intense model, they use JAX. So yeah, and also a lot of like code you see open source are the inference codes, not the training codes. So if you want to
Mm,
do inference, it's more about the usability, the user friendliness. If you want to do the pre-training itself, oh, you need like power, you need like superpower, and that's where JAX comes in. JAX is kind of like really powerful, but not every ML engineer is going to work on pre-training models. So it depends on your personal career goals. Do you see yourself, I don't know, DeepMind, or do you see yourself else, like at, I don't know, OpenAI, learn JAX, or Anthropic? Yes, you need JAX, or I don't know, the Cohere also uses JAX. I don't know if you're
nice.
familiar with Cohere. Yeah, so they use JAX. Meta uses PyTorch obviously because they started PyTorch, and but yeah, it depends on your goals. PyTorch is more user friendly. I'm going to tell you that. And in my previous job, we used PyTorch. PyTorch scales really well. Don't get it wrong. PyTorch is very good. I just feel it gets chunky at scale, right? PyTorch, when it comes to building stuff that runs on one device, it's really, like nice and cute. But when it comes to building massive model, training massive models, no, it's not.
Interesting.
Yeah.
Thank you. I think the last question on the question bank that came in, yeah, it's similar to what I just even asked. Do you think JAX is more suited for research or production level industry application? What has your experience been like in both?
Okay. So for research, people often think research is kind of like a simple stuff where you just, I don't know, they think, oh, ChatGPT, I don't know, open AI company or whatever, they just built one GPT model and called it a day. A lot of times you have to figure things out. You need to try different batch sizes for your training. You need to try different learning rates. You see what I mean? You need to try different strategies. So there's a lot of things to explore, and each of these, it could involve training different copies of the same model. So there's a lot of compute. So training is actually way more compute intensive than people think, because there's often like an experiment flow, right? So you often need to design the flow of the experiment, try this, try that, blah, try this. So imagine you're trying to sweep through a particular hyperparameter, just 10, like 10 different learning rates. You're gonna run the training on, like, let's say some, like data samples 10 times. So there's a lot involved in the R&D. So for research, that's actually why JAX was designed. So Google, they use JAX for research. They use TensorFlow for production at first. And OpenAI used JAX for research also. So a lot of like big research teams, kind of like JAX. And now for production level, if you want to deploy, PyTorch is very smooth when it comes to production, of course. And there's Onyx runtime. There's a lot of things you can do with PyTorch when it comes to deployment. JAX is super fast when it comes to deployment, but when it comes to production, if you're talking about like, I don't know, computer vision models and simple models, then JAX is super fast for it, right? It's good for inference. But if you're talking about LLMs, then you're better off porting the stable HLO. That's the graph representation I was talking about, and executing it in C++. So a lot of times you see like Llama, like C++ implementations of these models, like Llama C++, which people use for production inference. In JAX, it's actually very straightforward in the sense all you need to do is extract the stable HLO for your execution for your model, and you run it in C++. You don't need to recreate the whole model in C++.
Interesting.
Yeah.
Yeah. Okay, so yeah, I think I would go to the live stream chat and check questions. So the first question, I think we've answered or you touched it. So it says, how do you go about debugging when you get issues with JAX?
How do you go? It's the same thing. So with JAX, a lot of the errors you're gonna get from JAX is probably gonna be from your function not being pure, right? So I think one step is to fully understand what pure functions are, and to make sure you have that in mind when writing JAX codes for predictability. Else, the other kind of errors you probably see is, you can't reshape dimension of this into that. Typical NumPy and PyTorch and like bugs.
The next question says, does JAX work well with Hugging Face libraries, or in what scenarios will it be nice to use in an Hugging Face model training workflow?
So it depends for training or for inference. If it's for training, personally, I like JAX's training speed. So Hugging Face is highly optimized for PyTorch. So if you're taking your model from Hugging Face and you're comfortable with PyTorch, or you really want to use PyTorch, that is fine. If you want to use JAX, that is also fine, honestly. So with JAX, I feel if you want to like productionize the Hugging Face model, it's always more straightforward with JAX. Like I said, take your JAX model, extract the stable HLO representation of the model, and execute in C++ in production, and then there you go, your speed. But if you're not very comfortable, so I think I'm not sure if Hugging Face Trainer supports JAX training. I think it's PyTorch training. So yeah, it's a lot more seamless if you using PyTorch with Hugging Face. But if you're using JAX Flax, you should be able to like pick your Flax model and train it or fine tune it if you want to fine tune.
That's nice. Thank you. I think the last question on the live was, or is rather, are there scenarios in which you would have to develop a custom HLO parser?
Scenarios where you'd have to develop a custom I mean, it depends. You can't say there are no scenarios. It depends on the kind of project you're working on. At Cactus, my company, yes, we do need something like that. But that's for really, really very specific stuff. But double HLO, when you don't need to pass it yourself, a lot of times when you see the example, it's printed as text, right? So normally, so you sometimes we get confused to think that it's kind of like text. It's not. It's actually like a piece of program which you literally just save as it is, and then you take stable HLO and execute it in with OpenXLA, right? So you can execute it in your OpenXLA in C++, or you can load it in PyTorch and execute it. Or you can load it in JAX and execute it. You can load it in TensorFlow and execute it.
Wow,
So
that's
most times you don't need your parser unless I don't know you're working on something very new.
wow. Okay. I think that's the last question. Thank you very much, Henry, for this session, and I'm really grateful for making it to this session. And it has been very insightful. I would speak for people who are in the same shoes as me. It has been very insightful, and hopefully, I would have that boldness to open up my notebook on JAX and continue, because I think I dropped it for like a week or two. I was very, very scared about continuing. But yes, after this session, I definitely would pick it up and try implement things. So I would share the notebook now. Okay, yeah, you sent it. Thank you. I'll paste it in the chat section. So thank you, everyone. Yeah, in case you want to reach out, you still want to reach out to Henry, or you want to connect with him on his socials. His socials have been dropped. You can reach him on LinkedIn. At least I know that's where I reached out to him from. Or you can check out NanoDL on his GitHub, and the link to the notebook will still be shared via email, and on our community you can get it here. So thank you, everyone. So just a few announcements before we wrap it up. Yeah, for more updates, just follow us, ML in Lagos and Machine Learning Lagos, on Twitter or X and LinkedIn. Also, before we go, we have one more session for this September, for February. Why am I in September? We have this session in September, and it's on hackathons. So for anyone interested, you can register and you can come, and I can assure you that these two people coming are masters in hackathons, and they've been performing like really well in hackathons. So come around, learn how to win hackathons and how to get money, because me, I like money. So I'll definitely be at that session. So I think that's all. Yeah, and our upcoming events, we have an IWD event next month. More information about that will be shared. And as usual, our March technical session, our technical sessions run every month. And then our next office hours would be in April, and it's going to be someone from either Google or probably another GD. So yeah, just stay tuned for more information, and would provide more information on that. Yeah, would like your feedback to how did the session go? Probably there's one or two things that I wish could have gone better or could have been done better. This is where you can drop your feedback, and it is completely anonymous. You're not collecting any info, so that no one will wake up. You won't wake up at night and see someone holding something over your head. No, we are not going to do that. It's completely anonymous. Feeling, air your thoughts to us, and we would like to hear from you. Yeah, thank you very much, everyone, for coming. Thank you for tuning in. Thank you, Henry. Thank you, Roman, for joining in. It's been a wonderful time for me, and enjoy your weekend, everyone. So yeah, bye. See you in the next technical office hours. Bye.
Yeah, hopefully I get to talk about Cactus sometime in the future.